Hello Space Cats and welcome back to my channel. Rocket science is really difficult. For Voyager 1, just to get to the outskirts of our solar system, it's taken over 35 years. At this rate, 18 kilometers per second, it's going to take over 71,000 years just to reach our next nearest neighbor star, Alpha Centauri. This is 4.3 light years away. So how are we ever going to reach outside of our galaxy? In this week's video, I'm going to be talking about extragalactic space travel using black holes. When you jump, Earth's gravity pulls you back to the ground. But if you were able to jump fast enough, you would be able to escape Earth's gravity and fly off into space. This is exactly what rockets do. They have a minimum speed known as the escape velocity, which is given by the following equation. As you can see, it's related to the mass of the object who's pulling you down and inversely related to the distance you are from the center of that mass. Earth's escape velocity is 11.2 kilometers per second. To put that into perspective, have a think of the Guinness World Records for highest standing jump. It's 1.62 meters. That's equivalent to a jumping speed of 5.6 meters per second, 2,000 times smaller than what is required to escape Earth's gravity. To escape our solar system from the Earth, we need an escape velocity of 42 kilometers per second. And to escape our galaxy from the Earth, we need an escape velocity of 550 kilometers per second, or 0.02% of the speed of light. As you can see, it's going to be pretty difficult to reach these speeds, but we need to do so in order to escape the galaxy. A gravitational slingshot is where you use the gravity of a moving object to boost your velocity by swinging around it. Depending on your instant angle, this can be an acceleration or it can be a brake. For Voyager 1 to get the speeds that it had to escape the solar system, it performed gravitational slingshot maneuvers around Jupiter and Saturn. But this would not be enough to escape the galaxy. We need to go faster. So could we use a black hole? Well, the thing with gravitational slingshots is that it doesn't boost your absolute velocity, only the velocity in the direction of travel of your moving object. In most cases, this is the orbital direction. And also, if we get too close to the black hole, the tidal forces would rip us apart. Lastly, the closest black hole that we know of, V616 Monocerotis, is 3,000 light years away, so it wouldn't be the most effective way to get out of our galaxy. Have you ever been swimming or diving and warned of the dangers of rip currents? These natural phenomena are known to sweep swimmers and divers out to open sea, sometimes leading to their deaths. In space, this phenomena also occurs, and they're known as UFOs. No, not these things, ultra-fast outflows. These high-speed winds and outflows are emitted by feeding supermassive black holes known as active galactic nuclei. The most plausible explanation we have of UFOs is the enormous amount of radiation pressure that is produced from the enormous amount of heat when a black hole is feeding. In fact, it's believed that 30 to 40% of this matter falling onto a black hole is ejected as superfast winds. This is PDS 456. It's one of the most powerful active black holes that we know of. It is 1 billion times the mass of our Sun, and it can generate winds with speeds of 30% the speed of light. If we found ourselves in one of these outflows, we could exit our galaxy with no problem at all. In fact, we could go to Alpha Centauri in just 14 years. Unfortunately, we have some problems. First of all, the UFOs are comprising of highly ionized gas, and this means that if we were to enter an outflow, we would be torn apart by the radiation and the pressure. But let's say we could build a spacecraft strong enough to withstand this extreme environment. Even then, PDS 456 is over 2 billion light years away. It's so far away that we wouldn't be able to feel any influence of its wind at all from where we are. Our supermassive black hole, Sagittarius A star, is a much better candidate, but unfortunately it's not feeding right now. We might have to wait a long time before the right opportunity comes along. Another option we have is to use a tidal disruption event. This is where a star approaches too close to a supermassive black hole that it gets ripped apart by the tidal forces and spaghettified. Part of the stellar material will fall onto the accretion disk of the black hole, whilst the rest of it will be ejected out as ultrafast outflows, reaching 20% the speed of light. All we need now is to sacrifice a star to feed our black hole. So there you go. Who wants to build the first ever spacecraft to surf a black hole outflow? We won't know where we end up, but that's part of the fun, right? Let me know in the comment section below, and help me continue making great videos like this one by giving me a like, share and subscribe.